All right, welcome aboard, everybody. Recording is started, so we are going to switch to the slideshow and get started with this lecture. So this is exactly where we stopped last time. Okay, last time we stopped with this slide that said pretty much, okay, we are done with the syntax. We know the syntax of declaring an exception, or more specifically, declaring that a method is going to potentially throw an exception, throwing that exception from inside that method, and catching that exception in the code of whoever called the method. So the syntax maybe takes some time to get used to, but it's not a big hurdle. Okay, you're going to get used to it in no time. And we have some practice exercise to help you do exactly that. Now what we are going to talk about is what happened exactly at runtime. And there are just a few things maybe a little tricky, I don't know, that are happening at runtime that you need to be aware of. Most notably, until now, I've been talking about one method calls another method, and that other method maybe raise an exception. And the first method is always going to catch it. It's always returned so that there is a try block, and then after the try block, there is at least one appropriate catch block. So we have been rolling with those kind of examples that are like straightforward, okay? Now it's time to talk about the general case. So the general case involves what we call the program's execution stack, okay? So you know that when a method, like the main, for example, when the main calls another method, on the program execution stack, on the stack area of the memory, we pile up a new activation record. So there was already an activation record for the main containing its parameters, containing its local variables, all of that good stuff. And now we call a method, and that method needs its own activation record. It needs an area of memory where it can store its parameter, its local variable, and this kind of stuff. So there we go, we allocate some activation record for it. But now, if within the code of that method, okay, we call yet another method, well, then guess what? As soon as we enter the code of that third method to execute it, we allocate on the stack an activation record. And those activation records are going to stay for each of the respective method calls until we return from a method. So when we return from our third method, its activation record is gone. When we return from the second method back to the main, its activation record is gone. And the only time at which the activation record of the main method is going to be gone is when we finish, when we are done with our entire application. When we return from the main, that means our application shuts down, right? So at that point, the activation record of the main will also be removed from the stack, okay? So if we go like a little bit more in depth like this, we have a method that calls a method that calls a method that calls a method. So we have all of those memory structure that are piling up on the stack. And then after maybe like 5 or 10 of those calls, when we are deep, 10 calls deep into the stack, then suddenly somebody raises an exception. And the deal with the exception is that it's a way to communicate to whoever called you, right? So it's kind of like saying, I'm going to abort the current method, I'm going to wipe its activation record from the stack, and now I'm back into the code of the caller. The topmost activation record of the stack is the one of the caller, and I have this exception to handle. And if I don't handle it, what happens? I'm going to pass it to my caller. And if it doesn't handle it, it's going to pass it to its caller, and so on and so forth, until the term that is often used is bubble up, until the exception bubble up from the depth of the program execution stack all the way back into the main. And like I told you last time, if the main doesn't, it's kind of like our last line of defense, right? If the main doesn't handle the exception at that point, then it bubbles up one more time, and it hits the Java virtual machine, and that's it. Then explosion, okay? It's a Java virtual machine telling you, I encountered an exception, but all it knows how to do is shut down the app. You got an exception, I print out a message, I shut down the app. So you want to avoid that. You want to intercept it, before it goes all the way up to the JVM, okay? So it's that bubbling up, process, like how exceptions are transmitted from one method call to its caller, and then if it's not handled properly, to its caller and to the caller of the caller, and etc. This is what we're going to look at in this first example. All right, so we are going to look at code. You see the code here, like 3 panels of code, okay? The leftmost is going to be our main method. So there may be methods in different classes. The classes may be in different files. It doesn't matter for the sake of the explanation that I'm going to give you with those slides, okay? All that matters is that we have 1, 2, 3 method. And you'll notice that even though there are semicolon and curly braces everywhere, this is not actually Java code, right? This is like pseudocode. There are liberties here, like ... everywhere. Statement 1, well, statement 1 is not something we can use in Java, right? It's just represent one or more statements, a block of statement that we are going to label statement 1. Process X1, that just means process the exception, you know, that is referred to by this variable. So it's kind of a mix and match of pseudocode and Java. I hope this is not going to confuse you. If it does, please say something in the chat and I'll clarify anything that needs to be clarified, okay? But it's just to show the structure of a try-catch block, okay, in this method, and that method, and show that inside the try block, well, we are going to call over method. For example, here the main method invokes method 1. So this is a call to method 1 that is represented by this blue arrow. Then method 1 has some statements here, some work being done. Then we start a try-catch block. Some work is being done here, ... and then we invoke method 2. We call method 2. And then method 2, same thing, some work, try, some work, invoke method 3. Okay, and that's just like to give us like a template, and we could put inside those statement and whatnot, you know, we could fill in the blanks with whatever code we want. Okay, so we have a situation here where the main method calls method 1. Method 1 calls method 2. Method 2 calls method 3. And then method 3 is the one that's going to raise an exception. So we have like 3 levels, you know, on the stack, 3 activation record, 3 level of calling another method. So the basic rule is as follows, okay? It's even as follows, if you want to use proper English. If an exception is not caught in a method, in any method, okay, then that exception is going to be passed to the caller of the method. That's the bubbling scenario that I was talking about. So here, method 3 raises an exception. It's going to throw an exception. If I catch it with this catch block here in method 2, the one that called method 3, no problem. If I don't catch it, this is when it's going to start propagating. And method 1 is going to try to contain it. And then if it can't, it's going to be the main. And if the main cannot contain it, last line of defense, this is when the JVM is going to actually crash on us, okay? And the JVM crashing is just its default way of handling any exception, okay? Nothing special about that. It's just that if there's an exception that has not been handled by your code, then the JVM says, here's what I know how to do when an exception comes. I display a message and I shut down, and that's it. All right, so we are going to look at several scenarios. We are going to look at several examples where we are going to change the type of the exception that is raised by method 3. And if you look carefully at the code here, you are going to see that my first try-catch block here in method 2 is catching an exception named exception 3. So it's a made-up name, okay, just to mean that it's different from exception 2, which is different from exception 1. So each try-catch block here is catching a different exception, okay? So we're going to see how exception 3 passes through all of this. So method 3 is invoked here on this line. And now we start executing method 3. And at some point, method 3 decides, you know, I cannot go on like this. And it raises exception 3. All right, so the moment I raise exception 3, method 3 stops. I don't do anything more in method 3, including returning a value or something like that. I jump back here to whoever called method 3. That's method 2 right on this line. I do not execute statement 5 or anything else that would be left in the try block. Why? Because I was trying to do a bunch of things. One of them failed, I'm out. Okay, kind of like a break statement. I break from this line here to the first catch block. And like you know, there can be several catch blocks, and I'm going to explore them in the order they are written until I find one that matches actually the exception that was written. Exception 3 was the one that was raised. Well, looky here. This is exception 3 that we expect in that first catch block. So direct match. First time around, we have a match. So the object that was thrown, the exception object that was thrown by method 3 is captured here, if you want to use that word, is captured here by the reference variable x3. So x3 refers to the object that we created inside method 3 and that we threw back to whoever called us to say, hey, there's an exception here happening. And once I get this, then I can do whatever I want. I called it process x3. I can do whatever I want with this data. I can totally ignore it and just display a single message that says, you know, boom, and then that's it, exit maybe, or something like that. Or I can actually look into the object referred to by x3, try to get some information about what happened, and use it somehow to try to mitigate the problem or recover from it. So what you're going to do here is totally up to you, and it's case by case dependent, okay? It depends on what your application is supposed to do or can do in the case that exception, that particular exception is raised. And then what? So this code here can be more or less long, okay? Once I'm done executing everything in the curly braces that delimitate the catch block that matched actually exception 3, then I find myself at the next statement after the close of all of my try-catch block. So here we go, statement 6 is executed. So I went from there, skipped everything left in the try block, matched this first catch block, executed everything inside the matching catch block, then continued my execution as if nothing happened to the next statement after the try catch block. All right, so this is the most basic example. This is what we have been using last lecture. Okay, I call a method, it's risky, I catch as the exception that it throws. Always I have a catch block for the one or many exception it may throw, and I just mitigate the problem right there on the spot. Now, more interesting, example number 2. What if method 3, so it's still the same method raising the exception, but it's going to, this time, raise an exception called exception 2. Okay, so again, it's a made-up name. All that matters is that, well, exception 2 is not exception 3. That's what matters to us right now, right? So when I throw the exception, I break out of method 3, I abort method 3, I'm back here inside method 2, right where I called method 3. I'm inside the try block, so I go to the end of the try block, I check the first catch block. If this one looks for exception 3, well, I raise exception 2. So I just keep the entire catch block. If there was another catch block right after, I would check it as well. And then the next one, and then the next one. And when I run out of catch blocks, and I still haven't got a match, then what I do is I do not execute statement 6. So you know that I already skipped statement 5, like before. But now I'm going to skip through all the catch blocks that do not match, and I'm going to skip statement 6 because the moment I reach the end of the try-catch block and I was not able to handle the exception, I was not able to find a catch block that matches it, then at that moment, method 2 raised the same exception, exception 2. So it's not that it raised a new exception, it's just that it received exception 2 from method 3. It was not able to handle it, so we are going to skip anything else, any remaining code in method 2, and we are going to abort method 2, just like we aborted method 3, and the exception will propagate to whoever called method 2. Who called method 2? Well, it was method 1 right here. Invoke method 2, that poor row, right? So now, from the perspective of method 1, it doesn't know that it's actually not method 2 that raised the exception, but in fact, method 2 was calling another method that raised an exception, and method 2 was just unable to handle it. It doesn't care. Method 1 doesn't care. All that method 1 sees is I tried to do a little bit of work here. One of the steps of the work was to invoke method 2, to call method 2. And it aborted. It aborted with an exception. So I'm going to skip statement 3. So I'm repeating the same logic, right? It doesn't matter that method 2 called method 3 and so on and so forth. No, no, no. From this method here, method 1 perspective, all that matters is method 2 call failed. It aborted. There is an exception. So I skip everything else in the try statement. I go to the first catch statement and I try to match the exception that was raised with this class name here. Exception 2, yep, that's the one that was raised. So now I'm executing everything here in that specific catch block, the one highlighted in yellow. And when I'm done, I go back and I resume my work as if nothing happened. I execute statement 4. So statement 5, statement 6, and statement 3, all of those blocks were skipped. Okay? And it's really the same pattern that's going to keep repeating itself. So the worst case scenario in terms of complexity will be this one, example 3. So what if now method 3 right here raises an exception that's called exception 1? Well, let's run through it one last time. Method 3 raises exception 1. It throws exception 1. So the method 3 call aborts. We return here. Because we have an exception and we were in a try block, we jump to the end of the try block. Statement 5 is skipped. Matches with the catch block here? No match. Skip the catch block. Are there any more catch block? No. Skip statement 6. I abort the whole call to method 2 and pass my exception to whoever called method 2. Same scenario. Method 2 aborted. There's an exception. Skip everything remaining in the try block. So statement 3 is also skipped. Okay, so far statement 5, 6, and 3 have been skipped. I try to match my exception to the first catch block. Exception 2, it's exception 1 that was raised. So forget it. I skip this catch block. Is there any other catch block? No. All right, so I abort the entire call to method 1. I skip statement 4, and now I return back to the main, which is where I call method 1. Invoke method 1, it aborted, skip statement 1, okay, for the same reason, go to the end of the try block, catch exception 1, finally a match. So now that I match, this yellow highlighted catch block is going to be executed, everything in it will be executed, and then I resume execution with statement 2. And that's it. So always the same pattern, okay? Does it matter if during an exam or a quiz somebody gives you one method call or 50 method call? Well, yeah, it matters because 50 method call is going to take you maybe a little bit more time to double check and figure out, whether the exception is cut at some point in the process, right? But besides the fact that it's going to take more time, it's not going to be more complicated if you always focus on, one method being called from one other method. And then you just have to reason on that relation. And if that relation says the exception is propagated further, then you reason on those two methods now, and so on and so forth. And you could do it a million times. It just takes time, but it's not harder than doing it with one call only. Okay. All right. So what if the method is not caught in method 2 or method 1 or the main? I already answered that. Okay. Then the main method doesn't catch its exception 1 here. It's for example exception 4 or exception 0 that was raised originally by method 3. Then same process. Okay. Once we reach the end of all the catch blocks and we didn't get a match, we skip the remainder of the code. We abort the execution of the call to the main method, which boils down to pretty much telling the JVM, I give up, and the JVM will properly shut down and display an error message on our behalf. Okay? And that's it. So that's the bubbling up process. All right. So I have two remarks now coming up your way. We are going to try to tie up exception catching with inheritance. And we kind of already did that because all the exception classes, they are represented, like I showed you last time, by an inheritance hierarchy. Okay, so yes, inheritance is relevant to handling exception. It might be even more relevant than you think, and I'm going to insist on that one little specific detail now. What about the order in which you specify things in your catch blocks? Let me open up the code here and show you exactly what I mean. So let's say that we have, well, I'm trying to open the code, but the slides do not want to let me go. Okay, there we go. I'm in the main. Let's say I have a try, catch, and then another catch. I'm going to fill in the blank in a minute, okay? So I tried to call, let's go for method 3, okay? That was a culprit in our example. So method 3 is going to raise an exception. And then what I write here is exception. So I have to go with a general name because I haven't memorized at all the list of exception on Java. That's not exactly something that I do as a hobby. But okay, I'm going to use those two classes that I remember: exception, which is a superclass of them all, and arithmetic exception. Okay, and then what? And then I'm going to do some work here, and I'm going to do some work here. All right, let me try to get this to the point where it would compile. So right now, all those ellipses are not going to help. So method 3 does nothing, but at least it will compile. And let's say here, I'm going to do system.out.println, and I'm going to println exception detected. Then let's be lazy and cut and paste this whole thing. And I'm going to say arithmetic exception detected. And I'm going to say that method freeze potentially throws exception and arithmetic exception. Okay, let's see if I can get that to compile. If I can't, that's not a big deal. Method 3, should be able to fix that. Yeah, it's just because it's non-static. So let's make it static. Is that enough? There's still going to be an error when I'm done, but I want to get it to the point where this is the only error left. And that's exactly what's happening here. So before looking at the error message itself, okay, because it's going to give away the problem. So let me just show you why this code is temptingly looking good. This code looks good because syntactically it's correct, okay? And I seem to be doing the kind of job that I've been describing so far, which is catch one exception, one of the possible exceptions that method 3 may throw. Okay, there we go. I'm catching it here. And the other one, well, I'm catching it as well. So technically speaking, with what I've been presenting so far, there are no issues with this code. Well, so that's why we have this slide, because there is a little bit of an issue. The compiler will refuse to compile this, actually. And the error message is really interesting. It tells us line 12, so this is here, right? It tells us line 12, error, exception, arithmetic exception has already been caught. That's pretty cool. I don't know who coded it because I'm just trying to catch it here on line 12, okay? But if Java is telling me that it already coded somewhere or that somebody did the job for me already, I'm happy about that, but I still would like to understand what's going on. So what's going on here is a side effect of inheritance, okay? When I told you that if method 3 raises an exception, we are going to try to match the first catch block and then try to match the second catch block. When I say matching, I'm referring to, I'm trying to match the data type of the exception object that was thrown from method 3 to the data type specified here to declare the parameter e. Okay, so it's like if I'm passing a parameter to a method, right? So why, if I put it in this context, if I frame it like that, does anyone right now see why this might be a problem? And I'm going to put back the code, but I need to see also the chat window. Does anyone see what could be the problem here in terms of comparing this data type to the data type of the object that is thrown here, and then comparing this data type? To give you a hint, maybe, how do you compare a data type, how do you check the data type of an object? You can use an instance of operator, right? So I can say, all right, I got an exception. Let me use an instance of operator to detect whether that exception is actually of type exception. And then I will check if it's of type arithmetic exception. So Jennifer has a comment, doesn't exception include arithmetic exception? Bingo, awesome, perfect. So yes, it includes it, and it includes it why? Because of inheritance, okay? So we have an inheritance hierarchy, meaning that exception is a superclass of arithmetic exception. So when I get an object thrown by method 3, an object of class, let's say arithmetic exception, that's the example that interests us. I'm going to test here if an object of class arithmetic exception, is acceptable where I expect an exception. Yes, that's called polymorphism. Polymorphism allows us to pass an object of any of the subclasses when a variable, attribute, or parameter expects something of the data type of the superclass. Okay, so polymorphism and our friend upcasting are going to conspire together to do their job, and that means that they allow us to catch with the name exception any object, any exception object that is of class exception or of one of the subclasses. And that's why the compiler tells us it's able to see the type here, it's able to see the type here. It realized that arithmetic exception is a subclass of exception, so it tells us, oh, by the time you reach here, if I had an arithmetic exception object, it would have been caught already here. That's exactly what it means. Question from Garrett. Can you please remind me of why method 3 needs to be static? Can you handle exception in non-static method? You can definitely handle exception on non-static method. Let me show you why I use static method when I just want to illustrate something about methods, okay? So I'm removing the static. That's still okay, but I cannot call the method like I wrote here, okay? Non-static method 3 cannot be referenced to from a static context. So what Java wants me to do here is that I have to call the method 3 on an object. So I have to create this object equal new, blah, blah, blah. So what kind of object do I have to create? Well, the method 3 is inside the class, and here's the name, it's a long name, M4L1 live, okay? So I have to create an object of class M4L1 live just so that I may call the method on it. Now, if I do this, then Java is happy. It's still not happy about the arithmetic exception thing, right? But at least it allows me to make this method call. You see, Garrett? So I could definitely write it like that. The reason for which I don't usually write it like that is to avoid having to create an object and then call a method on an object, when really all I want to do is have a method that I can call, out of the blue from the main. So in that case, I put it in the same class and I just call it as a static method, okay? Now, back to that little problem that we have between the compiler and us regarding this issue here. I can't solve this issue if I do something like this. First, catch all the data type that has subclasses, and then catch the data type that is a superclass, okay? And if I had, for example, exception is a superclass of arithmetic exception, which is a superclass of you don't know how to count exception, okay? If I had like 3 classes like that in a inheritance chain, then I would put the most subclass first in my catches, and then the second one, and then the superclass, okay? If I follow this order, that means that if method 3 raises an arithmetic exception, the first thing I check is arithmetic exception. So I'm going to trigger this code. If it raises anything else, then it's not going to match arithmetic exception. And when I come to exception, then yes, it should definitely match every other possible exception, right? So I will show exception detected right here. Let's try it. Let's try to compile. Okay, there we go. Now the compiler is happy. So this is a little side remark, okay, but it shows that the interplay between inheritance, polymorphism, and even upcasting, even though it's done implicitly, okay, affects also the way exception work, okay? So it's just me trying to reinforce that idea that maybe you don't want to write polymorphic code, but guess what? If you are going to open a file and you need to know how to handle exception, you need to at least have an idea of what it means, polymorphism and stuff like that, so you may understand why you have to do things a certain way, okay? All right, so I think we covered pretty much what I had on this slide. Let me double check. The order in which the exceptions are specified in catch blocks is important, okay? And you should order things so that the catch block for the superclass appears after. This is a typo on this slide. This is after the catch block for a subclass. I'll check that and fix it. Hold on, let me fix it right now before I forget actually. There we go. So the version that I'm going to upload will have this little typo fixed, okay? But this is definitely after. All right, so watch out for that, okay? And it's all due to polymorphism and also upcasting. I didn't mention it on the side, but upcasting is also working in the background every time polymorphism is applying. So watch out for that little thing. Second little remark. So far, what we said is you can do two things. Okay, when you call a method that declare a checked exception. Okay, so if you call method 3 in our example, and method 3 declares that it throws a specific exception. Okay, and that specific exception is a checked exception, then the compiler will force you to deal with it. So what does it mean to deal with it? It means you have a try-catch block that is going to successfully catch it. That is what we did during the previous lecture. But during this lecture, the first example that we looked at together, we saw that sometimes your try-catch block is not going to successfully intercept the exception. So if it's a checked exception, okay, then you have to declare it. So going back to the code here, that means, all right, let's say that I call method 5 from here, okay, and I'm going to revert back to static method so I don't have to add extra code again here. So there we go, method 3. All right, and method 3 calls method 5, and method 5 is going to be doing this kind of work here. So let's say method 5 is the one that throws, let's just use arithmetic expression, okay? It throws arithmetic expression. And actually, let's use instead IO exception, okay? Just because IO exception is a checked one, arithmetic exception. I keep saying expression, sorry about that. Arithmetic exception is not actually a checked exception. So here we are. We are going to do something here, and maybe at some point we throw an IO exception. So this method here, method 3, needs to be able to catch the problem. So for example, do a try, catch, and let's say that it expects fully an IO exception. So it knows what to do when that happens, okay? And I'm going to put just a system.println here that says IO exception detected. Okay, so that's, again, that's what we did last time. Okay, and it's telling us that, yes, I forgot to put the variable here. So IO exception E, there we go. And that created even more problem. It's my static method, isn't it? Method is already defined. No, it's just that I forgot to rename the name of the method. So here we go. Method 3, method 5. That should work a little better. There we go. Okay, so where was I? Compiler is messing with my brain. So we were calling here method 5. Method 5 might raise IO exception. Like we did in the previous lecture, we handle it perfectly. So that's the first scenario, okay? The second scenario, I'm going to itemize it, scenario number 1 here, okay? The second scenario was, well, I'm trying still to intercept, you know, all of those problems, but I'm not doing a good job at it. So that means that, for example, here I say catch arithmetic exception, okay? Well, it doesn't throw an arithmetic exception, okay? And so here, what happens is a compiler tells me whoa, wait a minute. There is an unreported exception. I decided to catch and handle arithmetic exception, but since this method 5 may throw an IO exception and the IO exception is a checked exception, then the compiler puts its foot down and says you have to handle it one way or the other. So yes, I could add a catch IO exception, but that would put me back in scenario 1. Okay. So here, what if I don't know what to do? I don't have any clue on how to handle that exception. I just want it to propagate to whoever called me. All right. So if I want this to happen, then I need to declare throws IO exception. Okay. So I'm saying that my method 3 might actually end up throwing an IO exception. Even though in my code, I will never throw the exception myself. But I do know that method 5 has the capability to throw the IO exception, and I do know that I'm totally powerless if it happens. Okay, I have no idea what to do. So this is not going to happen by itself. Okay, you have, like the previous slide showed an example where the stuff was bubbling up by itself. So now let's go a little bit more in details. If you want a checked exception to bubble up, you are going to have to declare it in your method. And if the method that calls, well, it's a main, so it's a little different. I mean, but if this method doesn't handle things, then yes, it will crash, okay? But the idea is you have two possibilities. One is to actually catch the exception, or second possibility, to throw it, to declare it, okay? This is called declaring an exception. So you say that your method declares that exception. That means it's capable to pass it to whoever called this method. And that's what we refer to as declaring. So these are the two choices that we have been looking at. Okay, I'm just putting the dot on the I and crossing my T's, giving you all the gory details, if you want to call it like that. But these are the two possible behavior that we have to react to a checked exception. And the compiler will force us to pick one. Okay, I don't know if I compiled this, but did I compile it actually to show you? No, I don't think so. Right, okay, now that I've declared that I froze, that method 3 throws IO exception, then the compiler is happy. It says, okay, you don't catch it, but you declare that you throw it. That means everybody who uses that method will be informed that, hey, there's possibly an IO exception coming your way if things go south. Okay. All right, so these are the two possibilities illustrated here on a simpler example, maybe, okay, with more abstract names. So we have P1 and P2. P2 throws the IO exception, so that's like our method 5, right? A file doesn't exist, throw your new IO exception, a file doesn't exist, and then P1 decides to catch it. Here we are. And this version of P1 on the right just doesn't care. So you can have a try-catch block that tries overthink, or you don't even use a try-catch block, because really, if I'm not going to catch the exception that P2 may throw, then why do I need to even put it with a try-catch block, call it with a try-catch block around, and then what? If I don't have the need for a catch block, it's just going to be a try block? That doesn't make sense. If there are no exception that you are able to catch from P2, then you can even dispense of using the try-catch block in that case, okay? In my code example, I did have another exception that I wanted to catch, okay? So I had a try-catch block here, and it caught this exception. So scenario 3 could be, forget it. I'm just calling method 5, like so, okay? And this is going to be my scenario number 3, all right? I don't have anything else that I can catch actually from that method, so I just call it. And if something happens, I declared the IO exception. So I went the route of, if something happened, just pass the bucket to whoever called me, they will figure it out, okay? So catch and declare are not the only possibility. I mean, there's a two possibility that the syntax allows, but the syntax actually, even though we didn't mention it until now, also allows me to combine stuff together. So I can do a catch and what we call a rethrow, okay? So I catch the exception. The moment you catch the exception is considered handled, okay? For example, here, try, execute some statements, okay, and catch an exception named the exception. And if anything in those statements raise the exception, then we catch it here, we perform some operations, okay? So we try to mitigate what happened, we try to recover from what happened. But let's say that we cannot 100% recover, or we cannot 100% mitigate. So what do we do then? Well, in this example, we use the keyword throw, and we throw exactly the same exception that was passed to us. So we have to rethrow it because we already caught it. So the moment you catch it, it's not going to bubble up anymore. It's almost like it's handled, okay? But if I use the keyword throw, then I throw exactly the same object that I received, okay, in my catch block, and that means that here we go again. Okay, this method is going to fail. This method will have to declare that it actually throws potentially that exception, named the exception, and then the caller is going to handle it. So we can do both catch and rethrow. And to be able to do dethrow, that means we need to also declare in our method that we may actually throw this exception. Okay, so we use everything. We use the throw keyword, we use the catch keyword, we use throws with a S when we declare our method, and that's the third strategy to handle pretty much exception. I get hit in the face with an exception, I can do some stuff to repair the damage, but then I need to let whoever called me know that, yeah, the job cannot be completed. So it's up to them to try to recover at their level. Okay? So to sum up, we have considered different cases here, right? Different situation. So we have a table here that's going to try to summarize everything. And I do realize, looking at this, that this is not actually the last version of the table. Yesterday, I simplified those 3 cells here at the bottom. So I'm going to explain to you how we can simplify this further. So first, we're going to talk about 2 different types of exception. Are we dealing with an exception that is checked, so the compiler forces us to do something about it? Or are we dealing with an exception that is unchecked, in which case, do something about it if you want, you know, catch and throw, whatever, but you don't have to. I'm not going to give you a compilation error if you don't. So obviously, the checked case is the one where you do have to do things, okay? And those 3 cells here for the unchecked case, we could really simplify, and I will edit that again before to upload the latest version. We could simplify this and just say, you know what, do what you want. You may do something about it, or you may not. It's totally up to you. Okay, so those 3 cells are pretty much up to you. What are we talking about column-wise? So the first big column here tells us that you are blank a method that throws that kind of exception. So we're not going to play a round of Cards Against Humanity. In this case, I'll tell you what the blank is. For this column, the blank represents calling. So you are calling a method that throws that kind of exception. So here, I'm calling a method that is throwing a checked exception. Okay. Here, I'm calling a method that is throwing an unchecked exception. What are the 3 strategies that you may apply when you are calling a method that can throw a checked exception? You can catch it, so catch and handle it. So that means your code will recover. Okay, your code will do everything that you want to possibly do to recover from the exception, and then you resume execution of the rest of your method as usual, and your method will actually complete and return a value to whoever called it and stuff like that, okay? Or maybe you called a method, it raised an exception, and you cannot get over it. You cannot do anything about it. You cannot complete your own work because that other method failed. So in that case, you just declare the exception, and you let whoever calls you handle it. This is where it bubbles up. Or, third possibility that we just discovered on the previous slide, you can catch, do something to help mitigate the damage, and then immediately rethrow it because your method cannot complete its job if the method you called failed. So you do both, okay? You catch, mitigate a little bit, and then abort your method, throw the exception again. And in that case also, it is going to bubble up, okay? If we are talking about calling a method that throws a kind of exception that is unchecked, then again, once again, those 3 cells here, I'll edit it. That just means do whatever you want. You may try to do something, you may catch it and fix the problem, or you may declare it, just let it bubble up. In that case, you don't even have to declare it because it's unchecked. Or you may rethrow it. Okay, try to do something and then rethrow it so that the caller is going to handle it. And again, if you rethrow it, you don't have to declare it. Okay, it's unchecked. So it's pretty much very flexible here. And then the second column here is when the blank in that sentence is replaced by writing. So you are writing a method that throws either a checked or an unchecked exception. Well, in that case, it doesn't really matter. If you're writing a method that throws a checked or unchecked exception, at some point you're going to use the keyword throw, okay, to raise the exception. That's all you have to know. And then if it's a checked exception, then yes, there is an extra thing here. You should also declare it. If it's unchecked, you don't have to declare it, but if it's checked, definitely you have to declare it, okay? So again, this is not the latest version of that slide here that we're looking at. I clarified it a lot actually yesterday. I apologize for that. There was a mix-up on my part with the latest version of the file, but I will make sure to upload the latest version of the file so that the table is actually a little simpler to navigate, okay? But this is a summary of everything that we have covered so far anyway. Nothing new there, it's just a recap. There's one more thing. There's one more thing, and then we can look at examples, and we will be done actually with exception. It was a small topic. So finally close. So it's another element of syntax. After you are done listing all of your catch blocks, okay, you may have a last block, and there can be only one of those that's labeled finally. And you put some statements in it the same way that you put statements here or here. Okay, so it's just a block of code. The rule is that the finally clause, the finally block, is always executed, whether or not there was an exception that occurred here. So where could that be useful? For example, I try to open a file here, and I have some more code in the try block that say, first open the file, then read some data from the file, and then append some data at the end of the file. Okay, let's say I do all of this in the try block. So reading the data from the file and then appending data from the file, yeah, it's something that's totally dependent upon the success of me opening the file, okay? So that's why all of this is in the try block. I'm going to try to do all that, but if opening the file fails, then forget it, you know, I'm going to have to abort on reading the data or writing any data. Well, if opening the file raises an exception, I'm going to handle it here. I'm going to display an error message, log an error somewhere, or I'm going to somehow prompt the user to enter another name for the file, whatever I have to do, okay? And then I'm going to jump to finally. So even though the opening of the file failed at some level, I may have to call the close method to just free the resource associated with that file. I can do it here. And it's going to get done even though there was an exception. Okay. Similarly, if I run through this entire code here in the try block and everything works fine, then I'm going to skip the catch, but I'm going to jump to finally. So if I had any cleanup to do, again, closing file, you know, deallocating objects by setting the reference to them to null, stuff of that nature, then I could do it. So it's guaranteed that whatever cleanup, and we use it generally for this kind of cleanup, okay? Whatever cleanup you have to do, you can actually do it in a finally clause, and it always gets executed. So we're going to look at 2 examples now. We're going to look at 2 examples that are using exception, very simple examples again, but they are going to illustrate some of the weird stuff, again, that may happen. So first one, we are going to do some code tracing. All right, so we are going to take a look at a very, and it's going to be pseudocode again, okay? A very simple pseudocode that just handles, you know, call to a method that may raise an exception, puts a try block around it, and then a few catch statement, etc. And we are going to use that finally clause that we used, okay? Just to see how all of this works together. So here's the code, or pseudocode. Try, a bunch of statements, catch, the exception X, handle it, finally, more statements, and then statements that come after the whole try, catch, finally block. So scenario 1, no exception occurs. What happens? Statements gets executed. No problem. I told you that even if there are no exception, the finally block gets executed. So all of those statements gets executed as well. And then we go out of the block, the try, catch, finally block, and I execute whatever is left in this method. Okay? All right, so this is a normal flow of execution. No exception occurred. Scenario number 2. Exception 1 is thrown by, let's say, statement 2. So statement 2 throws an exception of type exception 1. Exception 1 is caught by my first catch block. Awesome. So I execute all of the statement inside that block. And then, remember the rule, the finally block always gets executed. So here we are, and finally, we execute the next statement. All right. So really, the only difference with the previous example is that, yes, this time we had to make a pit stop here through the catch. Okay. Scenario number 3. Exception 2 is thrown by a statement, one of the statements in the try block. So now this is interesting. I have several catch statements here, catch blocks. Okay. One for exception 1, one for exception 2. Okay. So let's see what happened. The exception is going to be caught by this block, the one that catches exception 2. No surprise there. But this block is doing a catch and declare strategy, meaning that it's catching the exception 2. It's doing a little bit of work to try to handle the problem. But then it says, you know what, that my current method cannot possibly succeed now that I got that exception. So I try to mitigate the damage, but I need to rethrow the exception. So I use that syntax, throw, and the same object that I received here is going to be thrown. Okay. Now here's the problem. Do I throw now or what? The answer is, of course, what? Because we said the finally clause always gets executed. So Java, even for looking at the code, I would be pretty much 99% sure that the next step is going to be throwing and aborting, right? Nope, the finally clause is guaranteed to execute, do whatever cleanup has to be done, and then only I'm going to execute that throw statement. And this is going to abort the whole method and send me back to whoever called me with an exception raised. Okay, so watch out for that. That's something that the quiz are going to test you on anyway, okay, the practice quiz. But yeah, there are a few oddities, and I'm trying to cover them all in the lecture so that you have a heads up pretty much on what's coming up, okay? Let's take a look at another example. So for this one, I'm going to just go through a basic example, and I'm going to make it sound like everything is okay, everything makes sense, and then we'll freeze on the last slide, and I'll ask you if you caught anything that actually contradicts what we have been learning so far with exception. So it's not easy because you're just discovering exception, okay, but play along with me. Keep your eyes peeled, pay attention, try to do what-if scenario at every step of the way, okay? So let's go back to our circle class. So we have a version of the circle class called circle with exception. That's the one that that has a set radius setter capable to throw an exception if we try to set the radius to a negative value. Okay, so what are we going to do with this? So here's some code, circle with exception, private double radius. So this is from an old example that we had at the beginning of the semester, where we have a static int number of objects. Disregard it, it's not super important for this specific example. Circle with exception, that's a constructor. It chains to the other constructor. The no-arg constructor calls the one-arg constructor. The one-arg constructor says, well, you gave me a radius. Let me set my radius to that value, okay? Then I increment the number of objects of that class that have been created so far, which is what this static attribute is keeping track of. So kind of basic stuff, even more basic stuff, get radius, get number of objects, find the area or compute area. I think we called it compute area before. These are basic methods, no surprise there. And then set radius is where the interesting stuff happens because, yeah, we're using exception. So I declare that set radius may throw an illegal argument exception. If the new radius is greater than 0, everything is fine. Otherwise, throw that new illegal argument exception. And we looked at that already in the previous lecture, okay, that specific example. I'm just putting it in the context of the whole class. And then we have a driver, like a test circle with exception class. It has a main, create 3 circles, one of radius 5, so that one should be okay. One of radius -5, so that one should break down. Okay, I should raise an exception, so I'm going to abort and go here to the catch block, handle the exception by just displaying the data inside the exception object, okay, as a string. And then after I'm done with that try-catch block, print the number of objects created was. And so since we keep track of the number of objects that are created in that static attribute, it should tell us pretty much that we did create one object successfully, okay? Then we failed at creating the second, and because we failed with an exception, we skipped creating the third one. So if I run this, that system.println here is going to call to string on X, which is going to generate that string that's going to be displayed. Java.line.illegal argument exception, radius cannot be negative, and then I'm going to resume execution here and display number of objects created, or I should say successfully created, is 1. So that sounds like a very basic example, and it is, okay? But even those basic examples can actually be used to kind of test whether you're like, you're like 100% ready to jump on any potential bug, okay? So this example is playing on something a little tricky here. The tricky part of this example is right here. I have a constructor. The constructor calls set radius, okay? Well, set radius is one of those methods that declared it was throwing an exception. And it does throw actually an exception inside of it. So everything here makes sense. But why don't I have to use a try-catch block here? Or if I don't want to use a try-catch block, I should have at least to declare, that circle with exception might actually let an illegal argument exception bubble up. So what's going on here? Why don't I have to do anything in circle with exception? And you may just, remember that little detail and be able to solve the problem like that, or you may be even able to make an educated guess, even if you're not 100% sure, what could possibly cause me not to have to do a try-catch block, or declare even that I want the exception to bubble up. So let me rephrase the question. Do you really care about every exception? Yes, there we go. So Mansi got it. That exception, so it's a two-level joke here that's going on, okay? That exception, illegal argument exception, if you look at the documentation in Java, it says that illegal argument exception is a subclass of runtime exception, which is a subclass of exception. But you remember, everything that's a runtime exception or below, these guys are unchecked exception, just like with the error, okay? Error is also another class that every subclass of it is unchecked. So yeah, because it's an unchecked exception, I don't have to handle it. But I'm looking at this code, and I could swear that I have to handle it, because look at what this other programmer wrote. First, this other programmer decided to throw an unchecked exception. Can we do that? Yes, we can. We can throw, we can declare, we can rethrow unchecked exception. Nothing forbids it, okay? It's just that the compiler doesn't force you to handle them. So I throw it here. I declared here. I'm 99.9% sure that I don't even have actually to declare it here. Okay, I'll have to test it. I'm not like 100% sure, but this could go actually. Okay, and then definitely when I'm on the receiving end, when I use that set radius method, whether or not it was declared here, it's an unchecked exception. That's what we do with unchecked exception. We don't care about them. We let them bubble automatically, and they do bubble automatically without me having to declare here. So it's the kind of exception that Java says, you know, like I explained when we introduced unchecked exception. This can happen anytime, anywhere. I'm not going to force you to have try-catch blocks everywhere or to have every single method you write declare that it may or may not be the victim of, you know, a list of 20 potential unchecked exceptions. So to make the code more readable, and because of the nature of those exceptions, we don't have to worry about any of that. Okay. All right. So the last thing that we can do with exception, so we learn to handle them. We learn to, and this is mostly what we're going to do in this class, okay? In this class, our priority is we want to use over people's code. So use the library, the documentation say this method raise unchecked exceptions. The compiler is going to yell at you. You need to know what's happening and what you need to do to stop the compiler from yelling at you, okay? But one other thing that we can actually define our own exceptions. All right, so define custom exceptions. So exceptions are class, so we know how to write classes. Fine, but the wisdom of Mordor, okay? One should not simply define their own exception because they can, okay? The problem is not that it's complicated. The problem is, what are you doing? Why are you doing this? We have already a ton of exception in the JDK, okay? So the first step is, if you decide one day that one of your method is, for example, going to complain about a parameter being out of range or something like that, there is an exception to do that. It's illegal argument. Now, if you don't like the fact that illegal argument is unchecked, then it's a totally different story. Then you may actually write your own exception because it's going to be a checked exception by default, and you are going to therefore force whoever is calling your method to pay attention in case, you know, they're not passing the correct arguments or something like that. So, but this is a process, this is a conclusion that you reach after you've established that, okay, no exception class in the JDK is currently pretty much doing the job that you need it to do. And it could be that it doesn't match the theme. It could be that, like in the example I used, you know, it's unchecked and you need it to be checked, okay? Or it could be that you want, for example, to have a subclass of one of the existing exception that's going to allow you to do more with it, to add methods or to add attributes, okay? So adding method and attributes, that's exactly what inheritance is about, right? So if you find yourself in a position where you say, well, whoever catches my exception, they get a variable, we always call it E or X or something like that, okay? So they get a variable, a reference variable E that refers to an exception object, but I want them to be able to call this and that method on that object. Well, then you are in a scenario where you need your own custom class, okay? So this is a kind of scenario situation where you would actually go toward writing your own exception. And like I said, it's not too difficult. I just don't want you to jump the gun and go too fast, you know, thinking, oh, well, I'm going to write all of my exceptions are going to be custom. No, it's better to use what's already there first, okay? So we're going to play again with that circle example and the set radius method that doesn't like when you pass a negative radius, okay? But this time, the one extra feature that we are going to use it as an excuse to write our own custom exception is that if I raise an exception because you gave me a bad radius value, I want to be able to save the value that you try to give me, okay? Just so that I can use it later, for example, in an error message or something like that. So let's take a look at how it's going to look like. So defining your own exception boils down to writing a class. Okay, so usual stuff. The class name is invalid radius exception. So it's not obligatory to use the word exception as the last word of the name, but it's kind of a convention. So I want to write invalid radius exception. I'm going to create a file invalid radius exception.java, put my public class in it. And here's the key. For my class to become an exception, it has to extend the class exception. That's it. So we use inheritance again, okay, that allows us to extend the Java framework. Okay, the Java framework has, I don't know, I'm going to say a number at random, 55 different exceptions. I need one more. I just extend, and that's it. I'm in business. And now I'm focusing here on the code that is new to my exception, that is special to exception. Again, that's what subclassing is about, right? So that fits the theme pretty well. I want an extra attribute that normally exceptions do not have. I'm going to call it radius. And my constructor, by the way, my constructor is not going to take a string. You've seen in all of the previous example I use when I create an object of class exception, generally, it's either I use no argument. I think I have one or two cases where I use no argument. I don't remember. Either I use no argument or I use a string. The string being the most common practice, actually, where I explain in a little text message, exactly what happened. Well, here, you're going to see that I don't need that string as a parameter. So when somebody raises an invalid radius exception, instead, I'm going to expect them to give me the value of the radius, okay? And then what do I do inside my constructor? I chain superclass constructor. So I call the superclass constructor using the super keyword followed by parenthesis. And inside the parenthesis, so the superclass constructor, it's a traditional, exception. It expects a text message that explains what's happening. So I'm going to build a text message for that constructor. I'm going to say, okay, here's what happened. There was an invalid radius, and I'm going to give you the value of that radius right after. Once I'm done calling the superclass constructor, okay, now I'm ready to store inside my attribute radius, okay, I'm storing the value of the radius that you passed as parameter, okay. The parameter from you when you created the exception object, I'm assigning it now to the radius attribute, okay. But I still made my superclass constructor happy. My superclass constructor doesn't know anything about radius. All it wanted is an error message, and I did give that to the superclass constructor. No problem there, okay? And then, just so that I may use the value radius later if I need it, get radius, an accessor, a getter method to the attribute radius, okay? So that's it. That's kind of a good illustration also of the power of inheritance, right? We just wrote the extra stuff. Everything else is inherited. So that means that now, everywhere that I used to use, name of exception classes, now if I compile my code alongside, that other Java file, invalid radius exception.java, well, now I can call that exception everywhere in my code. So here's my circle with custom exception class, the radius, the number of objects. Here's the constructor. The constructor throws potentially an invalid radius exception. Why? Because I'm calling the other constructor. That other constructor also throws invalid radius exception. That's why I have to declare it here, because this one, when I call it, may throw it. Why is this one obligated to declare things here? Because it calls set radius. And set radius, if I look at the next slide, right, it's going to, so this is what I was explaining here, okay? You have to throw because you call something that throws the stuff. It's not an unchecked exception, so the compiler will force you to write the stuff. And I call set radius, and set radius, let's go over the easy stuff like quick. There we go. Set radius throws that invalid radius exception, and it throws it right here in the middle of the code, just like before, except that now when I call the constructor, okay, I am not passing a string. I'm just passing the value of the radius, and my new exception class constructor will take care of building an error message and passing it to the superclass constructor. Okay, so it fits immediately in the Java framework. It's used exactly like I would use any other exception. Okay, so here's my main method, right? And I'm doing the same thing here. Okay, when I intercept an exception, do you remember that we put an attribute right in our exception class, a custom exception class? So now that I have a reference ex, okay, it's going to call the toString on ex, for example, and it's going to display the error message. Where is that error message coming from? Well, I wrote it myself. I wrote it here inside the constructor of my subclass. I said invalid radius followed by the radius value. So that's exactly what's going to get displayed this time. It's just a little bit more indirect. Okay, it's a good example to make sure that you are okay with inheritance, you understand what's happening. Okay, it's an application of inheritance to actually extending the set of exceptions that are available. Hold on. I have an assault on my keyboard from Sam there. So there we go. All right. And that's pretty much it. Okay, we're going to close the book here on exceptions. Okay. It's not a bad, like I said, it's not a bad module at all. It's not meant to be a hard module at all, okay? So what we focused on is how to use exception. This is exactly what I want you to focus on as you work through the practice exercise, okay? And then what we're going to do during the next lecture, well, we're going to round this up by finishing with just a typical use case. We're going to learn to deal with objects. Sorry, of course we deal with objects. This is an object-oriented programming class. We're going to learn to deal with files, sorry, more specifically text files. And as we do so, yeah, the method that we use are all going to raise checked exception that we need to handle. So we are going to do more of that try, catch, maybe rethrow a block. Will we be using exception in IE5? That's a good question, Garrett. No. IE5, did I already release that post or not? I have to double check. There is in the queue for release in Canvas, there is an announcement that's going to be posted, that's going to give you a heads up on what to expect for IE5. And IE5 is going to be focused on everything up to module 3 included. So polymorphism, upcasting, downcasting, yes, that's fair game for IE5, but nothing from module 4 on exception. Okay, I always try to put like a buffer of about a week when I can between the last time we talk about a topic and the exam on that topic, so that you have time to finish a practice exercise and stuff like that. All right, so I'm going to stop the recording now, but you know the drill, you know how this works. I'm not going anywhere. We're going to transition to office hours. So if anything is unclear about exception, please let me know, and I'll be glad to work out examples with you. Or if you have questions to help you prepare for the next upcoming intermediary exam, feel free to ask them. We'll work on that. All right, as usual, thank you for your attention.